Hey guys, let's look at vectors again, and we're going to look at the difference between polar and rectangular coordinates. Well, we're just going to use that. If you remember, the polar coordinates would sometimes use r and u to kind of refer to x and y, and there are two ways to tell somebody that you are, let's say, here. If the person's here, you can either say, well, you go over this many miles this way, and then you go up this many miles that way, or you can say, well, you go this many miles and at this degree, and you can find the person that way. And for your notes, I'm going to give you some notes where you actually can just have a very simple 1, 2, 3 step on how to convert the kind of problems we're going to do today. So go ahead and grab your notebook and copy these down, and we'll go ahead and get right to these. So, all right, well, let's look. The way we're going to convert and add vectors together, which we'll do some examples of this. It's actually kind of neat how this works, but first step is to write each one in rectangular form, which means you're going to actually draw the triangles, which again, you don't have to draw these nicely, just somewhat close to what they might look like, and make sure you're in the right quadrant when you do that. Okay. Step 2 is to add the horizontals and the verticals, and step 3 is to write in polar form. And let's do one. We're going to do a kind of a simple one first to kind of get us knowing what's going on. So you'll see how this works. So Fred leaves home, goes 20 miles at 20 degrees. We can just stop right there. Let's just draw it. Here's Fred. He leaves home. He goes 20 miles at 20 degrees. And this is a 20-degree angle. So let's just go ahead and even just write the, make the right triangle out of that. So we'll stop right here. All right. So let's figure out where he is at this point, how far over, in other words, almost like how far east he goes, and then how far north he goes. You could call it that way if you want to too. All right, well, let's find the r and let's find the u. Well, first we'll find the r. So we have this angle. This is adjacent, and that's hypotenuse. So adjacent and hypotenuse, that is cosine. So we have the cosine of 20 degrees equals r over 20. So we're going to need to find out, the cosine of 20 degrees. So 20 and cosine is 0.94. All right, so we have 0.94 equals r over 20. And of course, we just treat this like, a cross multiplication problem. So we're just going to multiply by 20. So times 20 equals 18.8. So we have the value of r at 18.8, and that'll be positive because on the coordinate plane here we're going to the right, which would be positive 18.8. This will be positive as well because we're going up with this y or u value. All right, so let's find the u. So we have, this is the opposite over the hypotenuse, and that is called sine. So the sine of 20 equals the opposite over 20 miles. So we're going to find the cosine, was that cosine? Oh, sine, we just did sine, okay. So we have the sine, and that'll give us 0.342. And we multiply that by 20, which will give us we'll call it 6.8. So here we go. We got our 18.8, and we got our 6.8, okay? Now, let's do the same thing. He says that from there he went 40 miles at 210 degrees. Well, we need to draw kind of an approximate value here. Well, here's 90, here's 180, and then we go 30 miles more. 30 degrees more, like this, and draw a little triangle. And here's our r, and here's our u. And notice that this r is going to be negative. So whatever it is, you're going to have to do something negative with that. We'll talk about that in just a second, okay? So that is 40 miles. So he goes 40 miles there. We need to find the r and the u. And again, we have 30 degrees, and we have the adjacent over the hypotenuse, and that is called cosine. So we need cosine of 30 equals r over 40. So let's go cosine of 30 on your calculator, and it is 0.866. And all we need to do is just multiply that by 40, because that's how far he goes out that way, and it is 34.6, we'll call it, okay? So this will be 34.6. Now, because it's going left on the coordinate plane here, like this x-axis, we're going to call this negative 34.6, so just keep that in mind. All right, let's go ahead and find what this u is going to be. And we have the opposite over the hypotenuse, and that is sine. So sine of 30 degrees equals the opposite over the hypotenuse. Well, let's find out what sine of 30 degrees is. I'm sure it's a real nice number. There it is, 0.5. Okay. Then, of course, we're going to multiply. We'll have 0.5 equals u over 40, and that will give us, if we cross multiply, 20. So this is 20. And, by the way, since we're going down on the y-axis, it is a negative 20. All right, now here's what we do. We have the r here as a 6.8. We have the r here as negative 34.6. All right, that's our r. We have the u, excuse me, that's the, my bad, that was 18.8 for the r. And we have this one as negative 34.6. The u here we have as a positive 6.8, but down here we have a negative 20. So all we need to do to find the actual r and u coordinates is to just simply add these together. So we have 18.8 minus 34.6 equals negative 15.8. So there's our r value, negative 15.8 r. And then we have 6.8 minus 20. If we were to do that, we'll get negative 13.2 u. And that is what we're going to do. In other words, if a guy goes 20 miles at 20 degrees, then he stops and goes 40 miles at 210 degrees this way, where's he going to end up? Well, I'll draw you a picture. Here's where he's going to end up. Negative 15 going this way. In other words, negative 15.8 going that way for the r. And then negative 13.2 this way. So he will end up as if he went right there from here, like that. So that's adding vectors. That's all you need to do. All right? All right, let's look at a different type here. And in your book, the figures look like this. Okay? We're going to add two different coordinates, and this is an interesting way we do this. All right? So let's first off, again, we're going to actually draw pictures like we always do. And don't have to be perfect. 30 and 55 degrees, which means we're going to go like that, and that's going to be a 30, and this will be 55 degrees. And we'll need to figure out the r, and we'll need to figure out the u. So let's just do that first. Easy enough. All right. So let's take 55. Let's find the r first. So we have adjacent over hypotenuse. That is, by definition, cosine. So we have cosine of 55 degrees equals r over 30. All right. So cosine of 55 degrees, doink. And we're going to multiply that by 30, and we get 17.2. All right, so we'll say this r is 17.2. There we go. Same thing with the u. We'll find out what that is, except for this time we'll use sine of 55 degrees, which is u over 30. Sine is opposite over hypotenuse. So sine of 55, and then yoink the sine. And then we're going to multiply that by 30, and that is going to equal 24. We'll call it 24.6. Okay. All right. So we have our two numbers. All right. Now they want us to add this to 10 and 170 degrees. So we need to draw another one. So here we go. We know again that this is 90, and to get to 170, we need to go 80 more degrees. So let's just draw an approximate. I know that's not 80 degrees, but good enough. Okay. So this will be 10, it says 10 miles long, or whatever it is. And this is going to be 10 degrees way down here, because we're almost at 180, all right? And here's our r, which is going to be negative this time, because we're going to the left side of the x-axis, we can call it. And we need to find out what this r is and what this u is, all right? And once we do that, we'll do something else and be done. Okay, well, let's look at, of course, again, we have this angle. It's adjacent over hypotenuse. So we have cosine of 10 degrees equals the adjacent over the hypotenuse, which in this case is 10. So cosine of 10 degrees, what is it? And it is that, okay? Well, we'll multiply this. You know what? We don't need to do that. It's an easy enough thing to do. So that's going to be 9.8, and we will call this negative 9.8 because it is going to the left on the left side of the coordinate plane there. Okay, well, let's go ahead and find the sine of 10 degrees, and that's going to equal u over 10. All right, and we'll go 10 degrees and then find the sine, and okay, that's 0.17. All right, so multiply that by 10, of course that'll be 1.7. This will be positive because it's going up. Okay, so we're going to add these two now. All right, and you know how to do this. There's your, let's look about our r's. Of course, this is our r here and our r there. So we'll do 17.2 r minus 9.8 r, and that will give us 17.4 r. All right, so that's what we're going to, excuse me, that's not right. That's 7.4. 7.4, all right? And we have the u's. We'll go up here. We have 24.6. All right, and we're going to add 1.7 because it's going up as well. And this is going to equal 26.3u. Okay, so we have a new drawing now we're going to need to make. All right, so we have basically, let's do a little erasing here and give ourselves a little bit of room because we're going to draw this now. We're going to draw this r, and we're going to draw the u. Then we're going to bring it back to our original type of coordinates here. So, all right, hold on one second. Get going slow here. Okay. All right, so get your calculators out again because you're going to need them to do some more converting. I know that's bothering you OCDers if I don't get all these. All right. New exciting color here. Heck, we won't use purple. All right. So here we go. Here's our, there we go. All right. So our r is 7 over. Okay. Yoink. Okay. And then our u is 26 up. Okay. So the thing is, we don't know what this is, but we do know that this is 7.4, and that is really tilted, isn't it? I bet that's bothering some of you guys. Okay, then 26.3 u. Okay, and we do not know what this angle is, and we don't know what this length is. Now the length is easy enough, right? This is a right triangle, kind of. All right, so we use the Pythagorean theorem. So we have 7.4, and then we square it, and we get 54.76. Let's just remember that. All right, 54.76. Then we have 26.3, and then we'll square that. We'll add that to 54.76, and then we will take the square root of that, which gives us, that can't be right. Let's try that again. All right, we'll go 7.4 squared gives us 54.76. Okay, delete that, all that. All right, 26.3 squared will give us this. Okay, all right, we will add that. Now, what in the world? Sorry, technical difficulties here. Okay, 26.3 squared equals that. All right, we're going to add. Okay, my bad, guys. I'm not sure what's going on here. Okay. 54.76 is what we got before. Okay, so we have 26.3 squared. All right, we're going to add 54.76, and then we're going to take the square root of that, which will give us 27.3, we'll call it. In other words, this length of this line is 27.3. There we go. All right. Now the question is, what is this angle? That's what we have to know. In other words, you're telling the guy how to find you here from here. You can't just, you can't just tell him, oh yeah, go 27.3 miles. Well, his first question is which way? Okay. So what we'll do is we're going to go, I mean, you can use tangent, cosine, sine, any of these sides you want to. Let's just say we go opposite over adjacent. How about that? Opposite is here, adjacent is here. So opposite over adjacent is called tangent, right? So we're going to have to find the inverse tangent. All right, so we'll take 26.3, divide by 7.4, and get something. And that ratio is going to give us the angle we need, because we just need to go inverse tangent in our calculator. So let's go 26.3 divided by 7.4 And that'll give us that. Now we're going to go inverse, which might be second on button on yours, and a tangent, and boom. We'll call it 74 degrees. Okay. And this will be 74 degrees. We'll do 74.2, what the heck. Okay. So what you will say is that the answer is 27.3, and it'll be 74.2 degrees. There we go. Okay. And that's how you add vectors that way and turn it back into our original type of our format there. So, all right, we'll give it a pause and try the practice problem on your problem set there. We'll come back in a second. Okay, well, here's the problem. Tracker left the cabin and traveled 25 miles on a heading of 20 degrees. Okay, so here's a little drawing, right? Here it is, and we'll go. We don't have to be perfect, who cares? Just draw something that's approximate. There's 25 miles, and there we go. Okay, from here she went 50 miles on a heading of 215 degrees. So here's our new drawing. All right, and there's 90, there's 180. How much farther does she have to go, the angle, to get to 215? She needs to go 20, and then 15 more. So here's our triangle we're going to draw. Okay, and this is 50 degrees, or 50 miles. All right, and 180 then to 215, again, would be 35 degrees. Okay. All right, let's find the first one. Okay, that's going to be 20 degrees, and we'll find the R, and we'll find the U. So we'll go first, adjacent over hypotenuse is cosine, right? So cosine of 20 degrees equals R over 25. Let's give it a whirl. Cosine of 20 degrees, trig, boom. There it is. Okay. And that's going to be multiplied by 25. Oops, I need an equal sign there. And that'll be 23.5, we'll call it. Okay. So in other words, this will be 23.5. Let's find the U. The sine of 20 degrees equals U over 25. Sine of 20 degrees, let's pop it in there. All right, and multiply that by 25. And we'll get we'll call it 8.5. Close enough. All right, so here we go. 8.5, there we go. All right, both of those are positive because the X, R is going to the right, which is positive, and the Y, or U, is going up. All right, let's try this one. We have our R here and our U here. Let's go ahead and find the R first. So we have, all right, we're going to need cosine of 35 degrees, and that will be R over 50 this time. All right, what is the cosine of 35 degrees? Let's find out. Here she blows. There we go. We multiply that by 50, and that equals, we call it 41. All right, so this is 41. And of course, we'll call this negative 41, right? Since it's going to the left side of the x-axis, we'll call it. All right, here's our U. We'll go ahead and use sine of 35 degrees equals U over 50. Sine of 35 degrees will be 35, and then sine, and then there you go. And we're going to multiply that by 50. And we're going to get 28.7. And that'll be 28.7. And don't forget, that will be negative 28.7 since it is going down on the y-axis. Okay. Now our job is simply, just to figure out, we're going to add these two R's and U's together. So let's go ahead and take the first R, will be 23.5. All right. And then the second R will be negative 41. Well, in other words, we'll call it 23.5R minus 41R. Okay. That is going to give you negative 17.5R. Okay, and that'll be part of our answer there. All right, I'll leave some room there. Okay, the second thing we're doing is going 8.5 for the U. So it'll be 8.5U. And then we're actually going down 28.7. So we're going down a lot here. So minus 28.7 u. All right. That'll give us negative 20.2 u, which I'll put right here. All right. So negative 20.2 u. In other words, this is the same thing as saying, if you go negative 17.5 r, that means you're basically going west for 17 miles and stopping. Then if you say I'm going negative 20.2 u, that means you're going 20.2 miles south and then stopping, and that's how far you end up from the village. So there you go. All right, you guys give those a whirl this week, and hope you have fun doing it. We'll see you soon.